All right, so before the break, we looked at solving polynomial functions when you were given a root or a factor, okay? So we're just going to look at this real quick, and we're going to break this down. So what we did is we learned to factor these. So we took this equation, and we turned it into x, because that's the GCF, x squared plus 4x plus 3. And we took that and we broke it down again into x plus 1x plus 3. And these became the factors. So the factors of this problem are x, x plus 1, and x plus 3. The zeros for that problem, we took the x, we set it equal to 0. We took the x plus 1, we set it equal to 0. And the x plus 3, and we set that equal to 0. And we solved each equation. Well, the first equation is done. That is x equals 0 is one of the answers. And then we have to solve the other two equations. So we end up with x equals -1. That's the second answer. And then the third answer was x equals -3. So before the break, we learned to factor, and we learned to solve, and we learned synthetic division. So we can recall that the zeros or x-intercepts of a function are found by substituting in 0 for y, and then solving it. We've also looked at when your functions cannot be your functions cannot be factored. So the previous example, it was factorable, but this problem is not factorable. And even though you might be looking at it going, oh, I can factor that by grouping because it has 4 terms, it actually can't be factored by grouping. It won't work out. So we learned how to do problems using synthetic division. But we learned how to do problems using synthetic division when we gave you something to start with. Well, today, you're not getting anything to start with. You've got to figure it out on your own. So we are going to use the synthetic division process, but we're going to use our calculator to help us get there. So let's take a look at this problem. In its simplest state, we know that there are going to be 3 zeros because the degree of the polynomial says that it is 3. From there, we're actually going to put our equation, we're going to take this equation right here, come on, that equation right there, and we're going to put it in the calculator where the y equals button is. And I'm going to show you where that is. So below my little shade here, I have my calculator set up where I have gone into the calculator where the y equals button is, and I have insert this equation into the calculator. So you go through the process, and I'll show you how to do that in class, or your teacher would have shown you how to do that. So we get that into the calculator. Get rid of all this. And then we go to the table. So in the directions up here, it says to go to the table. So right here, table. And so the table, I've also got that highlighted, is right here. So that'll be second graph. So here's my calculator. We hit the second button, hit the graph button, and we get a table. In other words, we get a set of numbers in a table that shows us x values and y values. And what we're looking for, let me scroll up and down so you can see that there are more numbers that exist. So here's the negative numbers. Okay. We have there's 0, there's the positive numbers, okay? So I'll get back to here. And so our table, I'm just going to write some of that down, says here's X, here's Y, and you're seeing things in the table like negative 5, 0. I'm not going to put everything down because I just don't have time to do that. I'm going to put 124, 2, 7, 2, 7, and I'm going to do 3, 0. 3, 0. All right. So what the calculator has done is this showed us 2 of the 3 zeros for this problem. Negative 5 and positive 3 are 2 of the answers. Negative 5 and positive 3. That means that there is a third one that we're still looking for. And it didn't show up in the calculator. It did not show up in the table of values. So what we can do is we can take this negative 5 and we can set up synthetic division. 1, negative 1, negative 21, and 45. And we can do our synthetic division with those values. 1, negative 5, negative 6, that's 30, 9, and negative 45. So that gives us a 0, which is what we want to happen. This is what we saw before fall break. And then we can take our negative 3 and we can do, positive 3, and we can do synthetic division again. So we'll do synthetic division again. 1, 3, negative 3, and that's negative 9, which gives us a 0, which is what we want to happen. From here, what you have is x minus 3 equals 0. And so now we can solve that, and we can say that our final 0 is another 3. So our last and final 0 was 3. And we used our calculator to help us get synthetic division started, and we used our degree to tell us how many answers we were going to have. Okay, sometimes calculator doesn't help. Okay, but there's another way. And for those of you that don't have a calculator that will help you find it, you can also do this. So this is using what's called the possible rational roots to find the zeros. So this is a little bit more time consuming. But what we do is we find all the factors of the constant, and we divide it by all the factors of the leading coefficient. And so in this first problem, number 2, here is our constant, and 5 is the leading coefficient. So the constant is 10, and the leading coefficient is 5, and so we set it up to look like this. So what we're about to list a whole bunch of numbers. So we take the factors of 10, which is the constant. So the factors of 10 are 1, 2, 5, and 10. Remember that factors are the numbers that divide evenly into a value. The leading coefficient, 5, the numbers that divide into 5 are 1 and 5. And remember that positives and negatives both divide into the 10 and the 5. So we have to include the positives and the negatives when we do this. And then we also have to use a brace to make a set of numbers out of this. Alright, so we're going to divide all the top numbers by all the bottom numbers. So we're going to take 1, 2, 5, and 10 and divide it by 1. So 1 divided by 10 is, 1 divided by 1 is 1. 2 divided by 1 is 2. 5 divided by 1 is 5. 10 divided by 1 is 10. Now we take those top numbers and we divide them. Let me get rid of this and do that part over again. Delete that. Then we're going to take the top numbers, 1, 2, 5, and 10, and now we're going to divide them by 5. So that's going to give us some fractions. So 1 divided by 5 is 1/5. 2 divided by 5 is 2/5. 5 divided by 5 is 1. And that 1 is already in the list, so I don't have to include it again. 10 divided by 5 is also in the list. That's 2, so I don't have to include that 2 again either. And these become all the possible rational roots. Now, as a trick question, there are 1, 2, 3, 4, 5, 6. There are 12 possibilities. So what those numbers become are numbers that we can use in synthetic division to help find our zeros. So we'll do that again for example 3. 1 is our constant, and 20 is our leading coefficient. So we're going to have a lot more fractions on this one. So the constant is 1, and it's only 1 is the only number that divides into 1. Leading coefficient is 20, so there's a lot of numbers there. 1, 2, 4, 5, 10, and 20 are all numbers that divide into 20. Doing the possible rational roots, is dividing the top number by the bottom number. So 1 divided by 1 is 1. And we get a move, because that's the only top number. So then it's 1 divided by 2, which is a half. And so it becomes the 1 divided by all the bottom numbers. 1/4, I'm just going to continue, 1/5, 1/10, and 1/20. Those are the possible rational roots, and just so you know, 1, 2, 3, 4, 5, 6, there are 12 possibles there. Now, in these questions, I get a lot of people ask me, what's the answer? The answer is this. What are the possible rational roots? Possible rational zeros. So there are 12 possibles that we might be able to use synthetic division with. So example 4 takes example 3 and says use it to find all the zeros. So hopefully you notice that example 3 and example 4 are using the same equation. So what we've done is we've found that there are 12 possible answers that are rational. But based on the degree, there's only supposed to be 3 answers. So what I did is I went and I put that equation into our calculator, because the previous problems were showing you how to use the calculator. So this is the equation that's in the calculator. We're going to go to the table, and we're going to see that there are no numbers in our table that work. There are no zeros. There's no zeros in the y column. So the calculator is not helping us here. This is an example of when the calculator is no use, and we have to use the possible rational solutions. So what we're supposed to do is guess an answer to use synthetic division. And so the easiest thing here to use in synthetic division would be 1. So if we take the 1, why 1? Because it's sitting right here. So I'm just going to use 1, 1, with synthetic division, 20, -4, -5, +1. And I'm going to quickly do synthetic division to show you that it doesn't work. We'll drop the 20. 1 times 20 is 20. Gives me 16. 16, 11. 1 times 11 is 11. And I get 12. See, we're supposed to have 0 right there. So that didn't work. Just like the calculator said. See right here, it says 1 gives you 12. So the synthetic division, we can't use the calculator here. 1 is not going to be a good number. That means that the fractions are going to be what actually works. That is not going to work. Okay, so let me get rid of all this work that we just did, and we get to guess a different answer. Now, when you look at this problem, you're going to have to use a fraction, okay? So you're welcome to try any of them that you want. But I already know a little bit more about this problem. Let me get rid of that. And we're going to go to 1/5. So we're going to use 1/5 in synthetic division. So I'm just guessing that this is going to work. So 1/5. I want to use purple. And I don't want to use red. 1/5 with 20. -4, -5, and 1. So we'll drop the 20. 1/5 of 20 is 4. -4 and 4 is 0. 1/5 and 0 is 0. -5 gives me -5. 1/5 times -5 is -1, which gives me a 0. And that is what we want. So I took a guess. I knew a little bit more about this problem than you did. And I got lucky. We'll just call it I got lucky. So this turns out to be 20x squared minus 5 equals 0. And now we can continue to finish the problem. So we'll just solve by square roots. 20x squared is going to equal 5. We'll divide by 20. X squared equals 5 over 20. So that is x squared is, I'll reduce it to 1/4. We'll take the square root of both sides. And x gives us positive and negative 1/2, as well as the 1/5 that we found in the original problem for the 3 answers to this problem. Let's put the whole thing together. So everything we've done so far, we're going to put it together. So example 5 on page 16 says list the possible rational zeros. So that takes the factors of the constant, that's 12. 1, 2, 3, 4, 6, and 12, and divides them by the factors of the constant. Sorry, the leading coefficient, which is 2, with 1 and 2. So our possible rational solutions are 1 divided by 1, so it's 1, 2, 3, 4, 6, 12 divided by 1. 1, 2, 3, 4, 6, and 12. And then it's 1, 2, 3, 4, 6, and 12 divided by 2, which gives us a half. 2 divided by 2 is 1. 3 divided by 2. 4 divided by 2, 6 divided by 2, and 12 divided by 2 are all already in the list. So those are our possible rational solutions. Now we check the table. So I've already input this into my calculator. And now we'll go to the table, second table. Are there any zeros? Yes, right here we got -3. -3 is a 0, so what I can do is I can go to synthetic division with -3. So what that does is it just helps speed us up. -3 with 2, 7, 11, 20, 28, and 12. So 2, so that's negative 6, got a 1. Negative 3 gives us an 8. Negative 24 gives us 4. Negative 3, and that gives me negative 12, which is a 0. So that we like. All right, so negative 3 worked, just like the calculator said it was going to. So here we had negative 3. It shows us the 0 is going to work. So let's scroll up and down to see if we can see any others. These numbers are getting really big, so that's not good. So we'll scroll the other direction. And that's not working. So there aren't any zeros there either. Which means that we're going to have to take a guess. So looking at the numbers, I'm going to guess half. So I'm going to use half in my synthetic division. I don't know that this is going to work. It's just a guess. So bring the 2 down. Half of 2 is 1. That's 2. Half of 2 is 1. That's 9. Half of 9 is 4.5, which gives me 8.5, which is not good. So half wasn't a good choice, so I've got to erase that work and start that over. So rather than completely starting over, I'm going to try negative a half and see if that works. So 2, bring 2 down. Half of negative 2 is negative 1, gives me 0. There's another 0, bring the 8 down. Half of negative 8 is negative 4, which gives us 0, which is what we want. So now we know 2 answers. We know negative 3 is an answer. We know negative half is an answer. So we just did step 3. That's step 3 right there. Okay? So we go down to step 4. Once the polynomial is depressed to quadratic, we now have a quadratic. So we have 2x squared plus 8 equals 0. Now we can start to solve using the rest of our methods that we know, like square root property, which is what I'm going to use. So 2x squared equals negative 8. We're going to divide by 2. We're going to take square root. And we're going to see that x is going to equal plus minus 2I, as well as the negative 3 and the negative 1/2 from above. And that is putting the entire process together.